Hey guys, I'm Derek with MillRight CNC. I'm going to show you how to use the Alpha Arc Plasma and do a basic little test cut. I'm going to walk you through how to do this in Fusion 360 and then show you what you need to do on the machine to get it done. As I said, I'm going to walk you through in Fusion 360 how to make that 2-inch square on the Alpha Arc. It's going to be super easy. First, I need to make sure I'm in the design workspace. There are a couple different workspaces we'll be in, but I'm going to start with the design workspace. I'm going to look at my document settings here. So I hit that little arrow. I'm in millimeters right now. I'm going to switch things over to inches. So now I'm in inches. I'm going to go to Create, Sketch, and I'm going to select this plane right here. And now my sketch palette is up. I'm going to go to Create Rectangle, Center Rectangle. I'm going to select this snap point. I'll click it, and as I start to expand, I can dimension it. So I'm going to hit 2 inches here. I'm going to hit the tab button. I'm going to hit 2 inches here, and I'm going to hit enter. From there, I'm going to finish the sketch. Now, I could do my plasma cam off of this sketch, but I like to have it as a solid body. So I'm going to right-click it, right-click the sketch, and I'm going to hit extrude, and I'm going to tell it it's 0.25 inches. Now, I want to add a radius to this because I want to demonstrate a little bit that we talk about in the operating guide about M666 and M667, turning the torch height control on and off. So what I'll do here is I'm going to hit this radius button here, or fillet, as Fusion 360 calls it. All right, and I'm just going to select each one of these edges here. So don't select this, but select the edges there. And it'll kind of see through there. If yours isn't seeing through, you can rotate over and click this edge. So I have 4 edges selected. And I'm going to make this 0.4 inches. All right. And there's a reason I'm doing that I'll show you in a second. All right, so from here, I'm going to switch over to the manufacturer workspace. Now that I'm in the manufacturer workspace, I'm going to go to fabrication if I'm not already there. I'm going to click the setup button. And on my stock, I'm going to select this lower left corner. But first, I'm going to go to the stock tab here. And I'm going to tell it I don't want any additional stock. Like, this isn't a milling operation where I'm going to mill something away. We're just cutting this square out of a larger sheet of steel. So I'm going to go to setup, and I'm going to select this bottom corner as my stock origin. Okay. I'll tell it okay. Now I see that my units are in millimeters here. I actually want to work in inches, so I'm going to click on that, and I'm going to go to inches. All right. From here in the fabrication workspace, or excuse me, in the manufacturer workspace with the fabrication menu, not a lot of options. We just have a 2D profile. Okay, so we're going to go to 2D profile, and I'm going to go up here to this second tab where I select the contour that I'm going to cut, and I'm just going to select this contour here. I'm going to come back over here and select my tool, and as I wait on that to come up, I'll explain that I already have some things set up here. So I have this available to you. There'll be a link in the operating instructions where you can get to it. This has some of the parameters already set up for the different thicknesses that are in the cut chart for this particular sink module. So on the Hypertherm 45 sink, this is the cut chart that you want to follow, and we talk about that extensively in the operating guide. But I have already saved a lot of these parameters, like what my kerf is for the different sizes. I've saved that in this library. So I'm just going to select steel 1/4 inch, and then I'm going to click select. And it already put things like my feed rate. So you can see it's got a feed rate of 46. And if I look at my cut chart here, the best quality cut setting is 46. One thing to know about this, some of these are driven by the settings or like the quote unquote tool I'm selecting. Like, it's all tool 112 because the Masso control to use the plasma it's tool number 112 always in the Masso control. But when I had that tool library, all I was doing was selecting different sizes that I had saved in there, so it would automatically load things like my cut speeds. There are other things that are going to be selected in the post-processor options, like these initial pierce heights and cut heights. The good news, though, with this particular cartridge on the 45 sync, whether it's aluminum, steel, stainless steel, they all use the same cut height and all use the same initial pierce height. There are definitely some changes when it comes to like arc voltage, but some of those there that I'll show you in the post-processor options are always going to be the same on this particular cartridge. If you go over to like the fine cut cartridge, then that's not going to apply, but we have charts in the operating guide for that you can follow as well. So I'll move this out of the way, and I'm just going to take a look at my lead ends over here, and I see it's doing a little bit of lead in. We'll just make that a round number, 0.2. I don't have to, but I've got lead in and lead out there. So I'm going to click OK, and I'm going to see what it gives me. So here I have my lead in and lead out, and it goes around with an offset that's going to do the kerf compensation. And again, the kerf is called out for here in the cut chart, and I have already saved it by saving that tool in my tool library. So it already knows that I have a 0.052 kerf. All right, now that we have our profile set up, we're going to move on to post-process. So I'm going to click this post-process icon. I already have the Masso Plasma post-processor as an option in my post-processor list. We cover in the operating guide how to set that up because you're not going to have it by default, most likely in Fusion 360. So we have certain things that we must set in these post-processor options to get a good cut. And I'm going to bring over another screen here and talk about that. So these are things to check or make sure you have set in your post-processor options. The ones in green are kind of set it and forget it. The one in yellow here is going to depend. You can read up in the operating guide on when we might want to use ohmic touch and when we don't. And the ones in red, if you're going to have a successful cut, you need to look at that each time and refer to our cut charts. So let's go through this a little bit. The cut height is always going to be set to 0.125 inches with sync module or sync cartridge, part number 428925. Initial pierce height, always set to 0.15 inches with the sync cartridge 428925. Probe feed rate, we recommend just setting this at 100 inches a minute and forgetting it. You may think that's a little aggressive. You can back that down to 50 or 30 inches a minute. 100 inches a minute is probably about the tippy top of what I would go on the probe feed rate. The THC Z-axis feed rate, that is the feed rate at which the Z-axis will move when it's under torch height control. The minimum THC radius, we talk about this in the operating guide. Let's just set that to 0.1 inches and forget it. Minimum, I should learn to spell, minimum THC feed rate, set that to 10 inches per minute. If we're going super slow, we probably want to have the post-processor turn that THC off. The ohmic touch, yes or no, that's just going to be, do I want to use ohmic plate detection? If you have the box checked, it's going to be, yes, I want to use ohmic. If you don't have it checked, then it's going to default to floating head detection. Again, refer to the operating guide for the section that we talk about when you might want to use ohmic, when you might want to use floating head. Using this 1/4 inch plate, I'm going to use the ohmic, so I'm going to have that box checked. Pierce delay and arc voltage, you have to set that according to the cut chart. All right, so I'm going to bring this up here, show you guys this. So again, the cut height, initial pierce height, those things are always going to stay the same as long as I have this particular sync cartridge in there. But things like that pierce delay and arc voltage, all right, so here and here, I need to refer to the cut charts to get that right. All right, so here I'm using 1/4 inch steel. I need a pierce delay of 0.6 seconds. My arc voltage should be set to 140. Now, you remember when I selected my tool, all my tool was I had saved different speed settings and kerf widths or kerf offsets for this particular sink cartridge according to the chart here with the different material thicknesses. So let's see how we actually put it in. All right, I'll move this back over. So the things that I need to make sure are set. The cut height set to 0.125 inches. All right, there we go. I'm going to pause here and talk about something important. Okay, 0.125 inches means 0.125 inches. If I was in millimeters here and this said 0.125, that interprets it as 0.125 millimeters. So I just recommend doing your cam here in inches. If not, convert these to the millimeter equivalents. All right, so the cut height, 0.125 inches. The pierce height, it says pierce height, same as initial pierce height, 0.15 inches. The probe feed rate, I have set to 100 here. The THC Z-axis feed rate, I have set to 25. The minimum THC radius, I've got at 0.1 inches. And ohmic touch, I have enabled here. I have this checkbox enabled because I want to use ohmic touch for it. Pierce delay, I need to refer to my cut chart. So pierce delay for 1/4 inch is 0.6. All right, let me move this away. Pierce delay 0.6. THC voltage, I have to set that. So I look here, and for 1/4 inch, it's going to be 140. All right, so I'll move this out of the way. I'll set that to 140. Again, don't get overwhelmed thinking, oh gosh, there's so many settings, because if you look back over here, once you set these up, it's pretty much the same every time as long as you're using this particular sink cartridge on the Hypertherm PowerMax 45 sink. All right, this is going to depend a little bit depending on, do you have a little floppy thin gauge plate, or are you cutting something that that you can use the floating head on, and maybe you've got a bunch of water on there. Refer to the operating guide for the do's and don'ts on that. But the big thing that I want you to take away from this is your pierce delay and arc voltage you need to set up in your post-processor options. These, you set it up the first time here walking through this with me, and you'll be good from then on, so long as you leave your units in inches. All right, so I have what I want there. I'm going to hit post. I want to overwrite that G code. Yeah, sure, I'll overwrite it. You probably won't get that because it's the first time you've done it. I'm going to view my G code here. And there's that G200 that was talked about in the operating guide. So all of those things that we filled in there populates this G200, and it tells the alpha arc how it's going to handle different things like the pierce height, cutting height. So you see all of those parameters that we entered are expressed here in the G200 command. And you see here where we've got like M666, it looked at this radius coming up, and it said, whoa, like that radius is under the minimum THC radius of 0.1 inches. So I need to turn off the torch height control. It finishes it, and then it turns it back on. So it seems like a lot, but just know as long as you set those parameters in there, most of which are set it and forget it, the CAM software, in this case Fusion 360, takes care of everything. So we're going to run this out to the machine. I'm going to show you the buttons to press, and we'll make a little 2-inch square out of some 1/4 inch steel. Let's look. So I've just put the program that we made in Fusion 360, I put it on this USB drive. So I'm going to insert that here into my Masso. So let's say I just turned the Masso on. It was going to ask for the password, which is capital H, capital T, capital G. Then I would have to cycle the e-stop. So that's just pressing it in and then turning it back out. I double click the home button. It'll be flashing yellow and say home, double tap. I do that, the machine's going to go home. Then I can go over to my F3 jog and probing screen. When you first do that, it's going to be set to step mode. I'm going to switch over to continuous, and then you can adjust your feed rate. There's a slider here where you can adjust that. So I'm going to go ahead and put this in my hand because I might use it in a second, my jog wheel. I'm going to come in here, and I'm going to now use this to get exactly where I want. So I'm going to push the screen out of the way so we can see a little bit. All right, I'm just going to put this about where I want it to be for starting the cut. So if you remember, we zeroed to that bottom left corner, like if you were doing a top-down look on it, that bottom left corner is where I zeroed out. So I'm going to set that origin appropriately. All right, so I'm going to come over here and position a little bit in the Y, just swapping over here to the different axes on my MPG hand wheel. I'm going to go ahead and Z down a little bit so I can see better about where I'm going. And like that looks like a pretty good start point for me. Cameraman, can we see our torch head there? Great. Okay, so I'm going to go to the F6 load file screen. I go to load file, and I named that test 2-inch square quarter steel. I'm going to hit load, and don't know how well you can tell from the video, but it's projected things out here. So I have a little icon, like a little white cross there, that's going to project where the cutting head is relative to my origin. So what I have to do there is I have to zero my X, Y, and Z for where I want the starting point to be. So I thought this location of the head was a pretty good one. So I'm going to hit X0, Y0, and Z0. And as I do that, that little white cross will go to the origin of the work. Alright, so I think maybe I want to move over a little bit. So I'm going to switch over to my X-axis and come back over here to the F3 jog and probing screen. And you see I'm moving the axis over. Maybe I want to move a little bit in the Y. I switch it over to Y there. And you know what? I'm happy, so I'm going to hit X0 and Y0 again. So before I start, I see 0, 0, 0 for X, Y, and Z. Alright, I'm going to stick that back down. I'm going to go over to F2, Program and MDI. I'm going to hit the rewind button. Okay, so F2, I'm going to hit rewind. I have my code up, and before I start, I know that I've got my hypertherm unit on. I know that I've got the air plugged into it. Obviously, if you don't have it on, you're going to get a no arc error, but I already know I have that on. So I'm going to hit the rewind button. I'm going to hit start cycle. The head's going to come up because I have a G-code in there to run up to a clearance height. The head's going to come up, and then it's going to come back down as part of its ohmic plate detection sequence. It's going to find the plate. It's going to come up to its initial pierce height. It's going to pierce, wait the delay, and then it's going to start traversing the THC. If you remember in the code, it turned on and off as it rounded that corner. So you may see the Z-axis make some tiny little adjustments in the straightaway and then lock down as it rounds the corner. Then maybe make some tiny adjustments. It may or it may not, depending on what the torch height control determines. But that's enough talking. Let's cut something. So I hit rewind. I'm going to hit start cycle, and I'm going to get out of the way. All right, so I'm going to talk loud here because we've got talk a little louder here because we've got the post flow, and now it's cut off. That's the post flow from the plasma. It's supposed to do that. So it keeps blowing through for a set period of time. And now I'm just going to fish out what I cut here. So here is my 2-inch square that we cut out. There's little bits of slag that you're going to have whenever you cut something. Most of this will flake right off in your finger, and then you can take a little slag hammer and do the rest. But that's your first cut on the Alpha Arc Plasma. Watch this video a couple of times so you've got a good feel for everything you're running. Contact our tech support if you have any questions. Show us what you make.